Today, we are rebuilding the cylinder head of a heavy-duty Daewoo DE12T diesel engine. In this tutorial, I will show you the professional process of installing valve stem seals, valves, retainers, and keeper keys, followed by cylinder head installation, torque procedures, and valve adjustment. If you are a diesel mechanic, truck technician, student, or engine rebuilding enthusiast, this step-by-step guide will help you understand the correct assembly process and avoid costly engine damage. Step 1. Cleaning and inspection. Before installing any engine components, thoroughly clean the cylinder head surface, valve seats, combustion chambers, and valve guides. Inspect the cylinder head carefully for cracks, damaged valve seats, bent valves, carbon deposits, and worn valve guides. A clean and properly inspected cylinder head is essential for good compression and reliable engine performance. Step 2. Installing valve stem seals. Now install the new valve stem seals. Apply clean engine oil to the valve stems before installation. Carefully press each seal into the valve guide using the correct installation tool. Avoid hitting the seal directly with metal tools because damaged valve seals can cause oil leakage into the combustion chamber, resulting in blue exhaust smoke and increased oil consumption. Step 3. Installing the valves. Insert the intake and exhaust valves into their correct positions. Apply assembly lubricant or clean engine oil to each valve stem before insertion. Move each valve up and down gently to confirm smooth movement inside the guide. Improper valve installation may lead to poor compression, power loss, overheating, or valve damage. Step 4. Installing springs, retainers, and keys. Next, install the valve springs and retainers. Using a valve spring compressor, compress the spring carefully. Install the valve keeper keys, also known as valve locks or collets, into the retainer groove. Ensure both keys sit evenly and securely in place. Improperly installed keys can allow the valve to drop into the cylinder, causing severe engine damage. Step 5. Cylinder head installation. Place the new cylinder head gasket onto the engine block. Carefully lower the cylinder head into position without damaging the gasket surface. Align the cylinder head correctly with the dowel pins before installing the head bolts. Step 6. Cylinder head torque procedure. Clean engine oil before tightening. Tighten the head bolts gradually using the correct crisscross sequence. Most heavy-duty diesel engines require tightening in multiple stages using both torque and angle tightening procedures. Adjust your special torque wrench to initial 6 kgm and start torquing from the middle to outward according to manufacturer procedure. Use workshop or service manual. For the Daewoo DE12T engine, the cylinder head bolts are tightened in the specified sequence from the center outward and typically in 3 stages. For engines using reusable high-strength bolts, apply an initial torque of 8 to 12 kgm, then increase to 16 to 20 kgm, and finally tighten to 24.5 kgm. For engines equipped with torque-to-yield, angle tightening, bolts, tighten first to 6 kgm, then rotate each bolt an additional 180 degrees, followed by a final 150 degrees turn. Always clean and lightly lubricate the bolt threads and tighten the bolts gradually according to the correct sequence to ensure proper cylinder head gasket sealing and prevent head distortion. Always follow the manufacturer's specifications and use a calibrated torque wrench. Improper torque can cause compression leaks, overheating, or cylinder head warping. Step 7. Rocker arm installation. Install the push rods and rocker arm assembly carefully. Lubricate all moving parts before tightening. Push rod installation should be carried out after ensuring that the cam followers, tappets, are correctly seated in their bores. Before installation, inspect each push rod for bends, wear, or damage and lubricate both ends with clean engine oil. Carefully insert each push rod through the cylinder head passage and make sure the lower end is properly seated in the tappet cup while the upper end aligns with the rocker arm adjusting screw. Incorrect seating can cause valve train damage and improper valve operation during engine startup. The push rod is a hardened steel component in the valve train that transfers the camshaft's motion from the tappet, lifter, to the rocker arm. As the camshaft rotates, the tappet moves upward, causing the push rod to rise and actuate the rocker arm, which then opens the intake or exhaust valve. Because the push rod is responsible for transmitting valve operating forces, it must be straight, free from excessive wear, and have smooth, undamaged ends. After all push rods are installed, position the rocker arm assembly onto the cylinder head, ensuring that each rocker arm is correctly aligned with its corresponding valve stem and push rod. Apply clean engine oil to the rocker shaft and contact surfaces before installation. Install the rocker arm mounting bolts gradually and evenly in several steps to prevent distortion of the rocker shaft assembly. Tighten the bolts according to the manufacturer's specified sequence and torque values. Uneven tightening may lead to rocker shaft damage, poor valve operation, or excessive wear. Incorrect seating can cause valve train damage and improper valve operation during engine startup. Your attention. Now onward, at the time where the mechanic bring all systems together to function properly. That is valve train mechanism. When torquing the rocker arm assembly on the engine, ensure that all push rods are correctly seated in the tappets and aligned with the rocker arm adjusting screws before tightening. Position the rocker arm shaft assembly on the cylinder head and install the mounting bolts finger tight. Tighten the rocker shaft bolts evenly in stages to prevent uneven pressure on the cylinder head components. Step 8, Valve Adjustment Procedure. Now we perform valve clearance adjustment. Rotate the crankshaft until the piston reaches top dead center on the compression stroke. Insert the correct feeler gauge between the rocker arm and valve stem. Adjust the screw until a slight drag is felt on the feeler gauge. Valve adjustment should be performed with the engine stopped and preferably at the manufacturer's specified temperature condition, commonly a cold engine unless otherwise specified. Rotate the crankshaft until the cylinder being adjusted is at top dead center, TDC, on the compression stroke, where both intake and exhaust valves are fully closed. Insert the correct feeler gauge between the rocker arm and valve stem, then turn the adjusting screw until a slight drag is felt on the gauge. This ensures the specified valve clearance is achieved for proper valve opening and closing. After obtaining the correct clearance, hold the adjusting screw in position and tighten the lock nut securely to prevent the setting from changing. Recheck the clearance after tightening, as the adjustment can shift slightly when the lock nut is secured. Repeat the procedure for the remaining cylinders according to the engine's firing order and valve adjustment sequence. Once all valves have been adjusted, rotate the crankshaft through at least 2 complete revolutions and perform a final clearance check before reinstalling the valve cover and starting the engine. This helps ensure smooth engine operation, proper combustion, reduced valve train wear, and maximum engine performance. Step 9, Final Inspection. Rotate the engine manually several times before starting. Inspect all valve movements, rocker alignment, and timing components carefully. Verify all torque settings and confirm that no tools or loose parts remain inside the engine area. If any unusual resistance is felt while rotating the engine, stop immediately and inspect the assembly again. Step 10, After completing the cylinder head and valve train assembly, install the external components, including the intake manifold, exhaust manifold, water canal, coolant passage assembly, oil coolant and cover, and valve cover. Clean all mating surfaces thoroughly and install new gaskets where required to prevent air, exhaust, oil, or coolant leaks. Mount the intake and exhaust manifolds onto the cylinder head and tighten the fasteners evenly to the specified torque. Next, install the water canal assembly and connect any coolant hoses or fittings, ensuring proper alignment and sealing. Finally, fit the valve cover with a new gasket, tighten the cover bolts evenly to avoid warping, and inspect all connections, hoses, and fasteners to ensure the engine is properly sealed and ready for coolant filling, final inspection, and startup. After installing all external components, including the intake manifold, exhaust manifold, water canal assembly, valve cover, fuel lines, coolant hoses, and electrical connections, perform a comprehensive visual inspection of the engine. Check that all bolts, nuts, clamps, and brackets are properly tightened and that all gaskets and sealing surfaces are correctly seated. Ensure that wiring harnesses, hoses, and pipes are routed correctly and are free from damage, interference, or loose connections. Also, verify that no tools, rags, or foreign materials remain in the engine compartment. Next, check all fluid levels before starting the engine. Confirm that the engine oil has been filled to the correct level using the dipstick and that the cooling system is filled with the recommended coolant. Inspect for any visible oil, fuel, or coolant leaks around the engine. If applicable, prime the fuel system to remove trapped air and ensure adequate fuel supply to the injection system. Recheck all service points to confirm that the engine is ready for safe operation. Finally, start the engine and allow it to idle while closely monitoring its operation. Observe the oil pressure gauge or warning light to verify proper lubrication and listen for any unusual noises from the valve train or other engine components. Inspect the engine for oil, fuel, coolant, or exhaust leaks and monitor coolant temperature as the engine warms up. After reaching normal operating temperature, shut down the engine and perform a final inspection, correcting any issues before returning the engine to service. Careful attention to assembly procedures, torque specifications, valve adjustments, and final inspections helps ensure reliable operation, maximum performance, and long engine life. Always follow the manufacturer's service specifications and take the time to verify every step before placing the engine into service. Thank you for watching this complete valve train assembly guide. If you found this video helpful, please like, share, and subscribe for more heavy-duty diesel engine repair, maintenance, and rebuilding tutorials. See you in the next video. Safe driving and happy wrenching.